Sri Satya Sai Lokaseva Gurukulam online classes. We've been learning differentiation of trigonometric identities. So far, we've also learned differentiation of algebraic identities and trigonometric ratios. In today's class, we are going to learn how to differentiate inverse trigonometric ratios. Before we move on, I would like to tell you a few things. Whenever you would have observed, whenever we differentiated algebraic functions, it led us to an algebraic function itself. So, a derivative of algebraic function was an algebraic function in itself. Whenever we differentiated a trigonometric function like sine theta, it gives to cos theta on differentiation. It gave to another trigonometric ratio. But interestingly, inverse trigonometric functions give rise to algebraic functions. Let's see how the derivative looks like. Every time what do? It's our procedure all the time that we usually use the first principle, find the derivatives, and then later on we derive all the formulas and use it for differentiation later, right? The same thing we will do now. Let's see how we are going to find the derivative of sine inverse of root x with respect to x by first principle. So, as usual, we will take let y is equal to sine inverse of root x. Since we are dealing with inverse functions, it's always easy to deal with trigonometric functions than inverse functions, right? I know, definitely you all would accept what I said now. So, I am planning to convert this into a trigonometric function. So, from this relation, I can see that sine y is equal to root x. Let me name this as 1. As always, we are going to give a delta x increment to x value, which is going to result on an increment of del y on y. So, after the increment, sine of y plus delta y will be equal to root of x plus delta x, right? So, let's name this too. If you have doubts in first principle, please go back to the previous videos, look into it, look into the procedure and then get back. It will be really easy. Now, so what we are going to do is, we are going to find the increment, we are going to do 2 minus 1. So, that will be the left hand sides, let's subtract first. Sine of y plus delta y minus sine y will be equal to root of x plus delta x minus root x. Now, how do I proceed? I don't have much choices, but I can see sine c minus sine d here. You all very well know sine c minus sine d is 2 cos c plus d by 2, sine c minus d by 2. Let's apply that. 2 cos c plus d by 2 will give you 2y plus delta y by 2. This is my c, this is my d. Into sine, c minus d by 2 will give me y and y will get cancelled, delta y by 2, and this is equal to, this side I can see that it is an irrational number. All that I know is to multiply by its conjugate. Let's try doing that also. So, x plus delta x minus root x, I'm going to multiply and divide by the conjugate, plus root x divided by root of x plus delta x plus root x. Now, if you look into this, this is a, this is b. So, this is of the form a minus b and this is of the form a plus b. You know very well that it gives rise to a square minus b square. So, when I square each quantity, the root gets eliminated. I get this divided by root of x plus delta x minus plus root x, right? Now, x and this gets cancelled. I'm left with 1 delta x. Let me bring it to this side because I'm basically looking in for delta y by delta x. And limit delta x tending to 0, delta y by delta x gives me dy by dx. I'm supposed to find dy by dx because my aim is to differentiate y, right? So, I'm going to bring this delta y this side. So, 2 by delta y, delta x cos of 2y plus delta y by 2 into sine of delta y by 2 is going to be equal to 1 by root of x plus delta x plus root x. Now I need delta y by delta x. So I'm going to multiply and divide by delta y. I've multiplied here, and let me divide it here. It's all one equation, just replacing it in different places for my convenience. Not only that, this 2, I'm going to take it and put it here. You all very well know that sin x by x, limit x tending to 0, sin x by x is going to give me 1. Okay, so I'm trying to bring that form here. Now I'm going to apply the limits delta x tending to 0. Here also limit delta x tending to 0. Whatever I do to the left hand side, I do to the right hand side also, right? Now, delta x tending to 0, delta y by delta x will give me dy by dx. So this limit is for this entire thing. So every term will be applied the limits for. Okay, this becomes dy by dx. And what happens to this? This does not have delta x, it has delta y. Now what do we know? When delta x tending to 0, delta y will also tend to 0. Where have we seen this? When we had done what is differentiation, in the initial videos, we have seen that when delta x tends to 0, delta y also tends to 0. In case you have doubts in this, please go back to the previous videos, watch that and then get back. Every time you watch a video, make notes of important points so that it is useful when you apply it in the future questions. So now, this is dy by dx, and here you know that delta y is also tending to 0, so this becomes cos of 2y by 2, that is cos y. And then this, when delta y also tends to 0, this is 1 is equal to, now delta x tends to 0, this is 0, so root x plus root x is 2 root x. So this is what I have. I'm supposed to find dy by dx. Let's find that. Now with this I know that dy by dx is equal to, I'm bringing this to the other side. It becomes cos of y. Now when you observe dy by dx, the derivative on the right hand side has y involved in it. That's not the way we express it, right? It has to be in terms of the independent variable only, not on the dependent variable. So now I have to put y in terms of its x back. Now what have we taken? We have taken y is equal to sine inverse of root x. So let me put it back. I will write 2 root x into cos of y is sine inverse of root x. Now does this answer look proper? It is cos sine inverse of root x. Doesn't look that good, right? If the sine inverse, instead of sine inverse, I have a cos inverse. Cos and cos inverse are inverse of each other, which gets nullified and will give me a better answer. So as I have told you, always the final thing depends on how we express the solution. So I'm going to express it in a different way. Let me see how I can convert sine inverse to cos inverse. So let me explain it to you. Let's take a triangle. I'm going to first explain in terms of sine inverse of x. Now we have sine inverse of root x, but let me give you an equivalence of sine inverse of x and cos inverse of x. Okay. So let's take sine inverse of x is equal to y. So from here we know that sine y is equal to x. On a triangle, when I have this as y, my sine is nothing but sine of y is opposite by hypotenuse, right? So opposite is this, x by hypotenuse is 1. So what is my adjacent? My adjacent is going to be root of hypotenuse square minus the opposite square. So root of 1 minus x square. So now what is my cos y? My cos y is going to be equal to adjacent by hypotenuse, that is 1 minus x square. So from here I can see that my y is equal to cos inverse of root of 1 minus x square. I have assumed y to be sine inverse of x. And I've got that y is equal to cos inverse of 1 minus x squared. So obviously, I can see that sine inverse of x is equal to cos inverse of root of 1 minus x squared. Am I right? I'm going to apply that here. I'm going to rewrite this as 1 by 2 root x into cos of, instead of sine inverse of root x, I'm going to write it as cos inverse of 1 minus root x the whole square into cos inverse of root of 1 minus root x the whole square. Because I have root x here, the angle has to be squared. So what do I get? I get 1 by 2 root x cos inverse of root of 1 minus x. Am I right? Root x the whole square is x. So now cos and cos inverse are inverse of each other. It gets nullified. Okay. So I have 1 by 2 root x into root of 1 minus x will be my dy by dx. I'm going to erase all the other things that are not really relevant that I had wrote to just explain you the relationship between cos inverse of x and in terms of sine inverse, right? So this is my solution. So my dy by dx is 1 by 2 root x into root of 1 minus x. It was indeed very long, right? It required a lot of knowledge. What is dy by dx? What is sine c plus sine d? Rather sine c minus sine d. What is sine inverse of x in terms of cos inverse? All these things you need to know when you use the first principle. So with that we derive a lot of definitions. So go back to the first exercise. Try to solve everything with the first principle and list down all the formulas for your convenience to apply it in the other exercises. So before we move on with the exercise, I'm going to give you few formulas. When you differentiate sine inverse of x with respect to x, you get 1 by root of 1 minus x squared. When you differentiate cos inverse of x with respect to x, we get minus 1 by root of 1 minus x squared. When you differentiate tan inverse of x, you get 1 by 1 plus x squared. So for now, we'll see these three identities, these three formulas. Later on, I'll give you the other inverse formulas also. So make a note of it. With that, we'll move on to the next question. Find the derivative of each of the following with respect to x and express the result in its simplest form. So we are supposed to differentiate. He's not asked you to use the first principle. So it means that you're free to use the formula and differentiate. So now, my first step would be as usual. Let y is equal to cos inverse of 1 by x. Now I'm going to differentiate with respect to x. So what do I get? I get dy by dx is equal to, as I've already given you, cos inverse of x on differentiation gives me minus 1 by root of 1 minus x squared. So here it is minus 1 by root of 1 minus, instead of x we have 1 by x the whole square. Now, am I done with my differentiation? No, I need to use the chain rule, because if you see, the outermost function is an inverse function and the inner function is an algebraic function. It's a rational function rather. So now how do I do that? Now I need to differentiate 1 by x. Now how do I differentiate 1 by x? I'll give you an easier way. 1 by x can be written as x power minus 1. And when you differentiate x power minus 1 with respect to x, use the power formula. So minus 1 x power minus 2, that is nothing but minus 1 by x square. Correct? So now when I differentiate 1 by x, I get minus 1 by x square. So I've used the chain rule here. Now I need to express it in its simplest form. Even if it is not asked, I've told you always expressing the answer in the right form is very, very important. As important as differentiation. Okay. Now I have 1 by minus into minus becomes plus, because this 1 by x square is only for this x, the square is for x, so minus remains itself. Minus into minus is plus. Root of 1, take LCM here, x square is the LCM. So x square minus 1 you get into 1 by x square. Now what happens? Here it becomes 1 by, this x square comes out of the root as x. So it goes on to the numerator. So it becomes x by root of x square minus 1 into 1 by x square. Now I cancel 1x square out, 1x out. So how do I rewrite it? Always the monomial first and then the binomial term inside the root. So this is my final solution. I hope you all understand. Please go step by step so that you don't get confused and you arrive at the right answer. So the next question is, find the derivative of the following function that we have. Look at this. So you can see that the outermost function is an inverse function. Inside it is a combination of sum of or difference of two trigonometric functions. We can use the chain rule, but it's going to be very, very complicated. Instead, we can use our smartness and try to express this in terms of tan of something. If you're able to express that, tan inverse and tan will get nullified and it will be very, very easy for your differentiation. Let's see if we can do it. So what we'll do is tan inverse of, let y be this. So I'm going to rewrite y. Here I'm going to write this as 1 by sine x, because cosecant x is that, minus cos x by sine x. Now this can be rewritten as tan inverse of 1 minus cos x by sine x. I'm sure you will remember all the trigonometric identities. You have that, you know that cos 2x is equal to 1 minus 2 sine square x, right? Now, 2 sine square x from this is equal to 1 minus cos 2x. I have 1 minus cos x here. So I'm going to divide the angle by 2 and find the half angle formula. So from here, I can very well see that 2 sine square x by 2 is equal to 1 minus cos x, correct? So let me replace that here. So I have tan inverse of 2 sine square x by 2 divided by, this is sine x. You all also very well know that sine 2x is equal to 2 sine x cos x, right? But I have sine x. So I'm going to divide the angle measure by 2, getting the half angle formula. So I have sine x is equal to 2 sine x by 2 cos x by 2. These are very, very important identities that you need to know in trigonometry for you to use it, apply it wherever required to simplify things. Now 2 gets cancelled. 1 sine x by 2, 1 sine x by 2 gets cancelled. I have tan inverse of tan x by 2. So tan inverse of tan x by 2 is nothing but tan inverse and tan gets nullified and you're going to get x by 2. So now your y has been rewritten like this. Till now we have not differentiated. We have not used anything at all. Correct? We have just rewritten what we have in terms of simplifying it and ended up in this. Now when I differentiate, it becomes very, very easy. dy by dx, 1 by 2 is a numerical coefficient and x on differentiation gives me 1. So when I differentiate this, I get dy by dx is equal to 1 by 2. Hope you all understood this. So we need to rewrite the things that we have in different forms, especially when inverse comes, to simplify it and then go about solving it. So let's move on to the next question. Next question is a similar one. So 1 minus 2x square. Now what identity will I use? Same way, I need to get sine here. That's my aim, not anything else, because sine inverse and sine will get nullified. So let's see. Again, we have cos 2x formula with us. And then it is equal to 2 cos square x minus 1, 1 minus 2 sine square x. Okay? Now, 1 minus 2 sine square x is nothing but cos 2x. Right? So, can we use that here? Let's see. Let x be equal to sine x. We'll take it as sine theta because we need to take another variable there. Let's say that x is equal to sine theta. Why am I doing that? You will soon understand. So here, let y is equal to this, whatever question that we have. Now we are going to rewrite this. So y becomes sine inverse of 1 minus 2 sine square theta. Now what is 1 minus 2 sine square theta? That is nothing but cos 2 theta. So this is sine inverse of cos 2 theta. Right? Now, how do I express cos theta? I need a sign here for me to get it nullified. Sine inverse and sine only will get nullified and not sine inverse and cos. You know the relation between sine theta and cos theta. Cos of 90 minus theta is sine theta, or sine of 90 minus theta is cos theta. So I can write it as sine of 90 is nothing but pi by 2 minus 2 theta. Pi by 2 is 90 in terms of its radian. So 90 minus theta is cos theta. Sine of 90 minus theta is cos theta. Now these two will get nullified and I will be left out with pi by 2 minus 2 theta. But theta is not a variable that's given to me in this in the question. So I need to replace it back. How do I replace it? It's sine theta is x or theta is sine inverse of x. So this becomes pi by 2 minus 2 sine inverse of x. This is my y. I've rewritten y now in its simplest form. It's much simpler than this. So now I'm going to differentiate y. So till now I have not differentiated. So now I'm going to differentiate y with respect to x. So what do I get? I get dy by dx is equal to pi by 2 is a constant. On differentiation it gives you a 0. And minus 2 is a coefficient, numerical coefficient, keep it like that. Sine inverse of x on differentiation gives you 1 by root of 1 minus x square. So my answer is minus 2 by root of 1 minus x square. And I've reached it in a very simple way in one single step after rewriting y according to my convenience. So as I told you, if you observe all your inverse trigonometric functions on differentiation gives you an algebraic function. Am I right? So we are going to move on. Find the derivative of each of the following with respect to x and express the result in the simplest form. Now, if you observe this keenly, will we be able to convert this into cos of something so that cos inverse and cos gets nullified? Yes, we can. Looking at it, I can substitute x is equal to cos theta because I have cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. This is an identity that we all know. So whenever you look into such angles for inverse, especially such values for inverse trigonometric functions, it's a pattern. You should know what to substitute where. So go through these videos, and whenever you look into such patterns, the substitution should strike. It should come automatically to your mind. So here I'm going to take x is equal to cos theta, so that I get cos inverse of 4 cos cube theta minus 3 cos theta. So this is nothing but cos inverse of, this is cos 3 theta. So cos inverse and cos gets nullified and you end up with 3 theta. Now theta is a value that I have assumed, right? But the question says x. Now I need to put it in its original form. So my theta is cos inverse of x. So I get 3 cos inverse of x as my y now. I have just rewritten y, that's all. Right? So now what do? 3 cos inverse of x is my y. So now I'm going to differentiate with respect to y. So you have dy by dx is equal to 3 is a numerical coefficient. Cos inverse of x on differentiation gives me minus 1 by root of 1 minus x square. So minus 3 by root of 1 minus x square is your dy by dx. Isn't it easy? So basically you need to find the pattern out and substitute. Let's suppose you have 4x minus 3x cube. Then it is nothing but sine theta should be your substitution. Why? Because we know that sine 3 theta is equal to 4 sine theta minus 3 sine cube theta. So understand and identify the identity that you have to use and substitute the right thing so that it gets very, very simple. Now, find the derivative of tan inverse of x plus tan inverse of x with respect to tan inverse of x. So always we used to differentiate y with respect to x. But here, this one with respect to the other one. So what do? You first take the equation like this and then differentiate with respect to x. So when I differentiate this, what do I get? I use u by v. What do you get? You have 1 plus tan inverse of x, the whole square on the denominator. Keeping the denominator a constant, you differentiate the numerator. So tan inverse of x on differentiation gives you 1 plus x square. Plus the numerator is kept a constant. Differentiate the denominator. Again you get 1 plus x square is equal to 1 by 1 plus x square. Right? Now, let's see what happens. Here, you have 1 plus x square as LCM. Let's simplify it. 1 plus x square on the numerator with LCM. Then you have 1 plus tan inverse of x plus tan inverse of x divided by, I'm sorry, here it is a minus. Here I've made a mistake. So this is minus. And so here also it's going to be minus because you all know the formula, right? So that's the mistake that I did. Instead of subtracting, I've added. So minus tan inverse of x divided by 1 plus tan inverse of x, the whole square, is equal to 1 by 1 plus x square, right? So now what happens? This goes off. So I have 1 by 1 plus x square into 1 plus tan inverse of x, the whole square, is equal to 1 by 1 plus x square. So this gets cancelled out and I get 1 plus tan inverse of x 1 by 1 plus tan inverse of x as my dy by dx. So, the derivative of tan inverse of x by 1 plus tan inverse of x with respect to tan inverse of x is nothing but 1 by 1 plus tan inverse of x the whole square. When you differentiate y with respect to x, you equate it to y, right? Similarly, when you have to differentiate with respect to tan inverse of x, take it equal and start differentiating. I hope you understand. That's all in this video. Thank you. Sai Ram.